Hi, Tiana. Am I audible?
Yeah,
All right. How are you?
good thing. Yeah.
All right. That's great. And all right. Today, actually, what I did, I have created a recurring meeting. So every time you have to join the session, you simply click on the link that I sent to you today, and then you'll be able to join. It will ask you to just, send a request. So I'll just approve it from my end, and then you'll be able to join the session. So I won't have to then send you the link again and again. This link will work every time when you try to join the session. Okay. All right. Okay, then just one second. Let me see if my charger is connected. Just one second. Yeah. All right. So we can continue. You sent some questions to me, right? Shall we begin with those questions? Okay. Should we start from the question that you sent yesterday, or even before you sent some few more questions? From which question exactly we should start?
I don't mind.
Okay. So I think the last time, that means yesterday, the questions you sent to me, we can continue with them, and later on we'll also cover the question that you sent earlier. Okay. All right, one second. I'll share my screen. Just one sec. Hmm, where is the whiteboard? Okay, can you see the whiteboard?
Hmm.
All right. So let's begin with the questions. I'll open the image that I got last time. Just one second. Mm, this one. Okay. So the questions which are circled, that's what we have to start with, right? Okay. So shall we begin with the question number J, one main J part? Okay, one second. I'll just get it on the board. I'll snip it and paste it on the board. Just one second. Can you also see the picture, the question image on the board right now, or is just the board visible to you?
The question.
Questions are visible to you, right? Okay, means
Yeah.
the whole screen is being shared. All right, then let me now paste it here. This is the question, right? And if you remember, I told you one thing, that there are certain hidden quadratic equations. Like, they don't look like the quadratic equation, just like this one. There is no power of 2. The basic thing that I told you, that the degree of an equation should be 2. So if it's a quadratic equation, right now we don't see 2 anywhere as a power here, right? But it's still a quadratic equation, and that's why it's called a hidden quadratic equation. Now what we have to do, just because x is at the denominator, we'll have to get the LCM here. This is a fraction, you notice. This is the kind of fraction over here, right? This is the fraction, but the other two numbers are not in the form of a fraction. So let's do one thing. Let's write them again in the form of a fraction. So how do you do it? You simply write 2 over 1, because 1 is the default denominator of any number. If any number is there, you can simply put 1 at its denominator without any problem. Even 7x can be written as 7x over 1. Then it's 5 over x. It's already there like this. And that's equal to 0. Any doubt till here? Now what we have to do, we have to consider a denominator which is common to all of them. So basically we multiply all the denominators, right? Now 1 times x is just x over here, right? We simply write x. So you
Hmm.
look at this. How many times 1 is x? If you multiply, basically this 1 has been multiplied by x times. So same number of times its numerator will also be multiplied. It means 2x. Even here, this one has been multiplied by x. It became x, means it got multiplied by x. Therefore, the 7x will also be multiplied by another x over here. We multiply one more x to that. Do you get it?
Hmm.
Okay, but look at this x. It hasn't got changed. It was x earlier. Even right now, it's just x only. It means there is no change. So we don't even change its numerator. Let us keep the numerator as it is. That's okay. Now this is in division, that goes into other side into multiplication. So it becomes, okay, 0 times x. That x went to the RHS, that is right hand side. Here we simplify this. It's 2x negative 7, and x times x is what? It's x squared. So we may write it as x squared right now. This is x squared plus 5. Okay?
Mm-hmm.
Yeah. Now what to do after that? 0 times any number is 0 only. So at the right hand side we just got 0. So 0 times x became just 0. We write it as it is. Over here we can just rewrite in the standard form. We write the second degree term, that is negative 7x squared first. We are just changing the places so we don't have to change the signs actually.
Mm-hmm.
2x is still positive, as you notice. There is no sign in front of it. Therefore it is positive. So it's plus 2x, and then this is plus 5. That's okay. Even this is fine, but if you are confused with the leading coefficient, if it doesn't look good to have a negative leading coefficient, you can still remove it. While there is no problem if you just start simplifying right from here, from this step. But still, if you want to make it more simpler, what you do, you multiply negative sign in each and every term. So when you multiply negative sign, okay, let me just write down, multiplying negative to each term. So that's possible. At both the sides, we'll have to perform this. So negative term become positive and positive term become negative, like this. Even 0 times negative will also be 0 only. There will not be any change in that. Do you get it now?
Mm-hmm.
If you have any doubt, then please ask. If it's difficult for you to understand. Uh,
That's okay.
okay, let me just tell you. See, simple thing is, let's say you got negative x plus y, right? Is equal to something. Say it's 3. You want to make it positive. It's still okay if you keep it in that way, but if you want to make it, if you want to make this x positive, you can still do that. What you will do, you will keep this side as it is and even this side as it is. You are going to perform multiplication with the negative sign. So you perform here as well as here. You perform multiplication of the negative sign at both the ends. So this negative changes the sign of each term here. So that becomes negative, negative become positive, and positive y becomes negative. Similarly, this becomes negative 3 right now. Same thing happened here. What exactly I did, okay, I'll just rewrite it. Exactly happened one thing, that we had this expression, suppose negative 7x squared plus 2x plus 5. That is equal to 0. What I did, I simply applied negative sign at both the ends, like this. So this negative got combined with each and every term here, like that, like this. So negative term become positive and positive term become negative. And negative times 0 is still 0 only. Okay? Alright then. So look at this. This is the standard form of the quadratic equation that we wanted. Question said to factorize, I guess. What question said? Question said to, yes, solve each equation by factorizing it. So we have to perform factorization right now. So how do we do that? We discussed few questions last time. Let me just explain here. So I'll just write the equation here. It's 7x squared negative 2x negative 5 is equal to 0. That's what is our equation, right? And the method is called splitting middle term method. Do you remember that I told you? So splitting middle term simply means we have to split this two either using addition or using subtraction. But right now we don't know whether which sign to be used, whether addition or subtraction. So what to do? Do you remember? To just figure out the sign in the middle, we multiply A and C. Can you tell the value of A here?
7.
7. What about C?
-5.
Correct. And that gives you negative 35, right? Just because this is a negative number here. So which sign you apply here in the middle? It's a negative sign. Had you got a positive sign right here, you would have applied a positive sign here. Okay? Okay. Now one thing is clear that 2 will be obtained using subtraction. Now how to get that? How to get those two numbers? So for that, what we do, we took this number. We just simply take this number, 35. We don't take the sign right now. We just take this 35 and we start factorizing it. So I just told you last time, we'll practice a little bit more later, but right now let's begin with this. So now this 35, whether it's divisible by 2, it's not divisible by 2. What about 3? Is it divisible by 3?
No.
Not even 3. Can we even think about 4 to divide here? No matter whether it's divided or not, but we can't even think about 4 because 4 is a composite number. That's not a prime number. So 5, yeah, 5 can divide it. 5 times 7 is 35. Now we even don't think about 6 because 6 is a composite number. Now 7 itself is a prime number, so it gets divided by itself only. Now we just got two numbers here, right? So that's really easy to consider 2. What we need 2 here. So definitely 7 negative 5 is what? 2, 7, negative 5. That's what the factors that we'll be using here. Every time we factorize the product we get here, all the factors are utilized to get the two numbers right here. Are you getting it? If you feel any confusion, feel free to ask me. Don't hesitate at all. Okay? Are you finding it's difficult?
If you had another one, would you take that away as well?
Which one?
Like if it did divide by 3, would you do 3 take 5 take 7?
It won't be divided by 3. It's not
No,
completely
but
divisible. Yeah,
if it could, if it was another number.
yes, if there was suppose another number, then you should have also used that to get that number. We would have made some combinations here, like 7 times 3, because 35 is what? It's a product of whatever number is written here. That's a product of all the factors that we get here. Just one second. Let me just give you another example. Let's say you got a number. Mm, say this is 18, right? So you first of all factorize it. So 2 times 9, then 3 threes are 9, and this. So 18 is what? 18 is the product of all these numbers only, right? If you multiply them, you will get
Mhm.
18 back again. And let's say you want to get 7. Suppose 7 is a middle term, right? And that's what you have to split using subtraction. So how do you get them? You have different methods, different combinations. Like you can multiply 3 times 3 is what? 9. And 9 negative 2 will be what? 9 negative 2 will again be 7. So we have to think in a different way. We have to hit and try. It's a kind of hit and trial method where we just multiply a couple of terms together and certain numbers are subtracted or added in order to anyhow get the middle number. One thing you have to keep in your mind that we have to utilize all the factors that are found in the product. We'll take a few more examples, then it will be more clear to you. I know it's a new thing, so it may be a little difficult, but don't worry. At the end, you will be able to understand that. I can assure you. Okay, so now what to do here? Don't subtract it again, because if you subtract, you will again get 2 back, so there is no use of that. Now what to do? You need to open the bracket. To open the bracket, what happens? This negative get multiplied from here, and that x also comes from the back. So what happens here? You got 7x squared negative 7x. Now at the same time, this negative is multiplied to this negative 5 and that x get also multiplied to that. So negative times negative 5 is what? Is it positive 5, right? Okay.
Mhm.
And x came from the back, so it's 5x negative 5. Is it clear in this step? Now we do one thing. We just group it in pairs. We make two pairs right now and we try to take something as common. So in the first group, you may see that 7 as well as x, they both are common. So we may take 7x common. So what is left here? Can you tell me? X,
X.
very good. And here everything has gone there, right?
Take 1.
1. So when nothing is left, 1 you can assume to be multiplied there and that's left over there. Similarly here, 5 is the common. So it's x and just because 5 has gone, so 1 is left. And that's what we wanted. Anyhow, we needed this thing actually. We needed x negative 1 at both the terms. So you notice this is my x negative 1. And even here we got the similar expression x negative 1. What we do, we take it further as common. So x negative 1 has been taken as common. So at the first term you get what? You get 7x, right?
Mm-hmm.
And over here you get plus 5. That's the factorized form of the given quadratic equation. See, this is the quadratic expression in the standard form, and this we've got in the factorized form.
Mm-hmm.
Most of the work is done till here. Now the only thing is to just get the solution. So for getting the solution, what we do, we can simply consider that equation for 2 times. I'll just rewrite here. 1 second. We have to write it twice. Just 1 second. Okay. So that equation just is written twice because I told you any quadratic equation has 2 solutions always. So at once what we do, we keep suppose this green bracket here. We keep this x negative 1 right here and we bring just because they are being multiplied. So when the other bracket goes to the other side, that goes into division. And that becomes 0 because it got divided into 0. And this is x negative 1 is here. So finally this is negative 1 goes to the other side, that becomes positive 1. So that's one of the answer here. Similarly, at this end what you do, you want to keep this 7x plus 5 at this end, and then you will bring your green bracket to the other side. So this is my x negative 1 and that becomes 1 second. Uh, it's 0 and 7x plus 5. So now 5 goes to the other side. That becomes 0 negative 5, just negative 5. And 7 is in multiplication. That goes to the other side into division. So that's your another answer for x. Yes, Tiana, let's start, try to understand it from the beginning. What happened? We have been given a hidden quadratic equation, which is not in the standard form. It's not in the standard form. So factorization can be done only if we have it in the standard form actually. The splitting middle term method can be applied when it's in the standard form. So for that reason, we assumed 1 underneath each number which is not in the form of a fraction. We've taken the LCM as x, we balanced their numerators like this, and finally we got this standard form. Even this is the standard form, right? We could have started right from here also, then too it would have been correct. But just because to make it more simpler, I multiplied the negative sign so that the leading coefficient is no more negative. And we are allowed to do that. If you perform multiplication with the negative sign at both the ends, that's quite acceptable. There is no problem in that. Okay. Now after that, what to do? Once we got this quadratic equation in the standard form, this is now in the standard form. So then we can apply the splitting middle term method. And to split the middle term, either we have to use addition or subtraction. So we were not aware whether what to use here. So for that, we have a trick to multiply A and C together. And if it becomes negative, you apply a subtraction sign. If it was positive, then you would have applied an addition sign here. Okay.
Mhm.
After that, what product you got, simply you have to factorize this. Once you factorize it, you get certain factors that are utilized to get that number. After that, we simply open the bracket, we regroup them, we've taken common. We finally have got this factorized form that can be written twice in order to get two solutions. That's it in the question. Okay. Do you want to take this snapshot or you want to note it down somewhere?
Um, I noted down the first part, but not the second.
Okay, so that means you got it. You saved it, right?
Oh,
Didn't you save this solution? If you want, actually, if it's needed for you, then you can save it somewhere. Did you do that?
yes.
Okay. Okay, so shall we go to the next question after that? Let me just stop sharing it again and I'll just try to share it again. Just 1 second. Mm, it doesn't let me to share only the whiteboard. I don't know why. Just 1 second. I'll try to share it again. Mm, okay, then no problem. I'm sharing it again. And then we can continue to the next question. Just 1 second. Today's dashboard is different than the previous session, or is it the similar thing? Like, can you see the
Um,
camera window, floating camera window that I'm just dragging on the board?
what?
Uh,
Sorry.
can you see the two camera window, like one is at your end and others at my end? Camera window I'm talking about. Can you do one thing? Can you just take the picture of your screen and send it to me on my WhatsApp so that I can understand how exactly it looks like to you? I just want you to just have a better experience. That's why. Just take a picture and then send it to me. 1 second. All right, means the camera window is not being shared, I guess. That's okay. That's okay, no problem then. It's fine. So let's continue with the next question. Oh, I think F was the first question. I just started from J. I should have started from the F question. That's okay. I think that was a better one to start with. It's okay. I'm going to start it right now. Um, this is the question, right? Again, it's not in the standard form. So what to do? We can assume this x to be x over 1. And this is already in the form of a fraction. So it's 2 over x. That is equal to negative 9 over 2. And one thing, see, negative sign is kept in front of this bar here, right? So no matter negative sign is, suppose there is a fraction negative x over y, you can also write it as x over negative y, or it can be applied exactly in the middle in front of this bar. All of them have the similar meaning actually, right?
Mhm.
Okay then. So right now what to do, at the left hand side, we get the LCM of 1 and x. That is x only, because 1 times x is what? 1 times x is x. Now look at this. This one got multiplied by what? By x, right?
Mhm.
Therefore, its numerator will also be multiplied with x. And this x hasn't got multiplied, or you can say it got multiplied by 1. 1 doesn't affect it. So even 2 is not multiplied by any number, or you can say 2 is multiplied by 1, so that won't affect it. So it's 2 only. Now what you have, you got this much. So it's x is squared plus 2. It says my connection has got some problem. Am I audible to you properly?
You froze for a minute, like a
Or
bit.
is it okay now?
Yeah, it's okay
All
now.
right. So what I was going to tell you, suppose this is what we've got right now. Now we have two fractions at both the ends. Let me tell you what happens. Suppose we have a over b, and at the other side you have p over q. You can perform cross multiplication like this. You can write it as A times Q is equal to B times P. It's called cross multiplication. So in the similar manner, what we do, we perform cross multiplication. Just 1 second, I'll get it at the next page. This one. So for performing cross multiplication, make sure to keep it in the bracket, otherwise it will go wrong. Because this 2 is considered to be multiplied to this entire expression. And if you don't apply bracket, suppose you just write it as x squared plus 2 and you bring this 2 to the side like this, it means that this 2 is getting multiplied to this 2, not to x squared. That's why it's needed to keep the bracket here. And this x goes to the other side here towards -9. Is it clear till this step?
Mhm.
Okay, now this 2 get multiplied to each term using the distributive property. So it's 2x squared plus 4 equals -9x. We also bring 9x to this side. So 2x squared, 9x becomes positive, plus 9x. Actually, you would have got this thing, see, plus 4 and then plus 9x. But just because the standard form is what? Ax squared plus bx plus c. So first of all, we keep the squared term. Then we keep the bx term, that is 9x. And then we keep the constant term, that is c, in the standard form. Is it okay? So we got this standard form now, and we can now perform factorization. So let's write it here. It's 2x squared plus 9x. Now this 9 is the middle term actually, right? This 9 is the
Mhm.
middle term, and plus 4 here. That is equal to 0. Again, we have to split it either using addition or using subtraction, but we don't know right now whether to use addition or subtraction. So for that reason, what you do, you have to perform multiplication of A and C. You multiply this A and C term, that gives you positive 8. So what does that indicate? What sign you
You
apply
have
here? It's addition,
positive.
correct? Correct, very good. It's addition here. Now, to get those factors, you simply factorize this 8. So 2 4s are 8, 2 2s are 4, 2 1s are 2. Now one thing, even if you consider all of them here, you still don't get 9, right? So when these many are insufficient, you can also utilize the later one, which is at the end. That's a method. When these factors are insufficient to get that number, see, when you multiply 2 times 2 times 2, how much you get?
8.
8. This gives you 8. And what is 8 plus 1?
9.
Yeah. So just because we didn't have, most of the times that many are sufficient, we don't have to use it. But if in certain case these are not sufficient, so we can also utilize the last one, that is 1. So yes, we can use 8, and this is where we have 1. 8 plus 1 is what? It's 9. Okay, let us then simplify this. We simply open the bracket. See, 1 times x is what? Just x only, right? Or you can write 1x, that's still okay. You have got 2x common here. So you are left with x plus 4. Now what's common in the second pair? Can you tell me?
1.
1 is common. Very good. If nothing is common, 1 can be taken as common. So it's x plus 4 left only. Nothing is taken out. X plus 4 is common in both of the expressions, so we just take it out as common. X plus 4, 2x plus 1 equals 0. That is the factorized form that we wanted. Now once we got this factorized form, what we do, we have to write it twice. Okay, let me write down. This is x plus 1, and then we have, sorry, it's x plus 4 actually. Then this is 2x plus 1. I'm writing it twice so that we can solve it together. There is another option to just not to write it twice, simply equate them equal to 0. But that's a perfect way that you can use to represent the answer. So once you got that equation, you simply rewrite it twice. And once you keep this, suppose red bracket, so you bring this blue one to the other side. Underneath 0, this is 2x plus 1, that simply becomes 0. So x plus 4 is equal to what? 0. X equals negative 4. That's one of the answer. Similarly, this time you want to keep this 2x plus 1 to this side, and you will now bring your red bracket to the other side, which is x plus 4. So you know what to do. Now this becomes 0, so 2x plus 1 equals 0. 1 goes to the other side, that becomes negative 1. 2 goes to the other side into division, so negative 1 over 2. That's the answer. Okay? Now just go through it from the beginning and then tell me if you have any doubt in the question. Yes, Triana. I feel like you are hesitating to ask anything. Feel free to ask me. Just consider me as your friend and then ask whatever you want. Don't hesitate at all. In any step, no matter how small that step is or how silly that, whatever is, nothing is to hesitate. Just simply ask me whichever you want, any step that you found difficult. Yes, Triana,
Um, I understand it.
you understood. That's okay. And what about this part?
We do it different. We were taught that like to factorize that differently. No, like after that, like the
After
9x, like
this
no,
one,
sorry,
9.
the 2x. No, the when you get it into standard form,
Okay, yeah, this one. Okay, after this. Yes,
yeah,
there are different
we were
methods. There
told
are,
it.
okay, yeah, there are different methods, but sometimes those methods have some limitations. And that's the reason I don't teach that method to the students. Because in certain cases, when you have negative leading coefficient, that gets failed. So that's why I'm telling you this method and just, I assure you this method is the perfect one. It's a universal one. No question can go wrong if you understand this method. So if you believe me, then you can just go with this method. And definitely, this is the universal method. I have tried a lot of methods from the US textbook and Australian textbook. This method I found very, authentic and universal. If once you understand, I think it's a little difficult to start with, but once you understand it, you will be able to solve any kind of quadratic equation with the help of this method. Okay. All right, let's begin the next question. I think this will be then more clear to you. I'll just show you. This is the next question, the Q part. I'll get it on the board. Again, this is not in the standard form, right? So for that reason, what you do, you keep the terms in the form of a fraction. So 6x over 1 negative 49 over x plus 7 over 1. That's equal to 0. And then you get the LCM of 1 and x. That is x only. Now 1 times x, that means x times it got multiplied. So its numerator get multiplied with x. This hasn't been changed right now, so we don't even change its numerator. It's kept as it is. Again, this 1 got changed by x times. Therefore, we multiply x to its numerator. Is it okay? Now we bring this x to the other side just because it's in division. It goes to the other side into multiplication. And here we've got 6x is squared negative 49 plus 7x. Now this is still not the standard form. Finally, we can just write it in the standard form. 6x is squared. Now we write x term in the middle actually. That should be written in the middle in order to represent it in the standard form. Plus 7x. So what is 7? 7 is actually nothing but the middle term. And then we have negative 49. That's a good question to understand it. I'll show you how to do it. Now again, we have to split the middle term, and right now we are not aware what exactly to use, whether addition or subtraction. So okay, we just consider a question mark here, and we go with the method that we have been doing, that a times c. What's the trick? That's a trick actually. Just remember it as a trick to identify the sign here. The trick is to multiply a and c terms together, right? So what is a right now? 6. And the c is negative 49. So when you multiply 49 times 6, that gives you 294. Negative 294. It's a negative value, right? So
Mhm.
definitely the sign that's going to be used here is a negative sign. Now you need to get two numbers that on subtraction can produce 7. So that can be obtained when you factorize 294. I think I can do it at the next page, then it will be more clear to you. So this is 294, and we try to factorize it. So initially we'll begin with 2, right? 2 ones are 2, 2 fours are 8, 2 sevens are 14. Do you get the system? How did we do it? Actually 294. We only write the quotient, like 2 ones are 2, then it's 9 is noted down, 2 fours are 8, then 4 is noted down, so 2 sevens are 14. So 147. So I just wrote 147. We don't write this much thing. Okay, I'll undo it. Now again, it's no longer divisible by 2, but it's divisible by 3, I guess. Yes. 3 fours are 12, 3 nines are 27. Now it's directly divisible by 7. I'll tell you some divisibility rules actually. How come I know that it's divisible by 3, not by 2? There are certain divisibility rules that I'll tell you later, okay? So, okay, I'll just have one special session on the basics of calculation that will really help you to understand these many things that we often use. Okay, so that many factors we got, right? And the target is to get 7 here. The target is to get 7 on subtraction of two numbers. Okay, what do you think? Any idea? Two things you have to keep in your mind. That you have to utilize all these factors. None of the factor will be left away. It has to be taken, like all the factors should be taken, involved actually. And there are certain combinations you have to make. Okay, I'm just helping you right now. See, 7 times 3 is what? 3,
21.
3 times 7 is 21. Let me just write down. 3 times 7 is 21. And now when you multiply 2 and 7,
14.
14. That means we involved all of them. 2, 3, 7, 7. We involved all of them, right? And what is their difference? 7. So we write 21 negative 14. 21 involves 3 and 7. 14 involves 2 and 7 together. Is it okay? If you don't get, I'll again tell you. Don't worry. Should I explain it again?
It's okay.
Okay then. So 21 and 14, these are the two numbers that will produce 7 on being subtracted. That's the main thing you got using that factorization. Okay, so we simply write down this is 21 and this is where we write 14. We open the bracket now. Now we regroup them in pairs again. This is the first pair we have. This is the second pair. Now, Tiana, what we do, we have to take something common. You notice here 3x is common maximum here because 6 can't be divided in 21, so we don't take 6 common. It's just 3 and x is common, so we are left with 2, and this is x. And over here, when you divide 3 in that, you get 7. X has already gone there. What you take common in the second group? Any idea?
-7.
Very good. You have to take -7 so that you get again positive terms inside the bracket. That's really nice. So now, okay, 7 times 2, that is 2, and that x, and 7 times 7 is 14. And that's positive because you take a negative sign, so it came from both of them. Negative gone out from both the terms, and it left positive behind. That's good, that's perfect. And now what you do, you further take it out as common. 2x plus 7, and this is 3x negative 7. That's equal to 0, and that's a factorized form. Any doubt till here? Okay. Now, rather than writing it twice, the other way is, once you got this equation, suppose 2x plus 7, and the other term we have is 3x negative 7. Rather than writing it twice that we have been doing in the previous questions, what we did, we used to write it like this. Rather than writing like this, you can simply equate it equal to 0. That's still okay.
Mhm.
This is equal to 0, and 3x negative 7 is equal to 0. That's the other alternate method, which is a little shorter one. So 2x equals negative 7, x equals negative 7 over 2. That's your first answer. Similarly, 3x equals positive 7, x equals 7 over 3. That's the second answer. That's it. Yes, Triana, tell if you have any doubt in the question now. Yeah, you can start from here. You can just start understanding from here. Then I'll open the next page. Any trouble in
Yeah.
that steps? Okay,
No.
then what about this? Okay, this is where you understood we got the negative sign using this symbol that it's negative. That's what you understood, right? Now, how do we get 21 and 14? Let me explain that again. Once we got this 294, we factorized it, and the target is to get 7 on subtraction. We have to utilize all these factors. We have to make different combinations. We could have even tried this way. Let's say you had 2, 3, 7, 7. You could have tried 6, and that would have been given 49. So it would not have given you that 7, right? 49 negative 6 would not have given you. So we don't do that. There are different combinations possible. So with your intelligence, you have to actually frame it in such a way that can produce the desired number. And that's what we did here. We did, it comes with the practice actually. So we just considered 3 times 7, which is 21. This is what? This is 21. And 2 times 7 is what? 14. And 21 minus 14 is 7. Right? That's what we written
Mhm.
here. And then further we've taken things common out, and then that's it. We finally got the answer. Okay?
Mhm.
All right. I think I'm recording today's session. If you don't want to take this snapshot, I'll share this link so that you can mm, go through all the questions. Let me just see if I think it's, oh, 1 second. Let me see if it's being recorded or not. Oh yeah, it's being recorded. That's okay. Correct. It's being recorded. So, all right. I hope you understood this question. Any doubt in this? Okay. We are done with all these three questions. You may tell if any other question other than these three I should explain in this one.
I did H, but I got it wrong, and I'm not
Okay.
sure why.
Don't worry. I'll tell you this. Question number H. That's a question. Again, it's not in the standard form, right? Have you been taught ever certain special formula like a plus b whole squared? Have you been ever taught this thing a squared plus 2ab plus b squared like this?
Yeah.
Okay, so that's a special formula a plus b whole squared. If it's a negative b whole squared, then it can be written as a squared negative 2ab plus b squared, right? Similarly, there is another formula a plus b, a minus b. Can you tell me the value of this?
Um,
You can still multiply.
A,
Yeah, tell.
I,
It's a
is it just
squared
A squared?
negative b squared. Yeah, that's it in the
Oh,
formula. You can still perform long multiplication and then you will get the same result actually. So whether you simply memorize all the formula, a plus b squared means what? It's a plus b times a plus b. When you perform multiplication, you will still get the similar thing. So just to save the time, we often memorize the formula. But if you still don't memorize, don't simply go for long multiplication. That's still okay. Right now, I'm just going to do it using the formula. Isn't it kind of a minus b, a plus b form?
mm-hmm.
So we can use a squared minus b squared formula, right? So a squared means x squared. And what is b here? Can you tell me?
-1.
Just 1. Because in the formula we
Oh,
have a plus b, we itself has a negative sign, right? So just 1 you will have to write it. A squared minus b squared. Because here it's positive also. Here it's 2, let's keep the 2 as it is. Within the bracket, we can expand it using this formula, a plus b whole squared. The formula is a squared plus 2ab. B is 1, right? Plus b squared means 1 squared. So we simply, okay, I'll tell you another way also. This is the simpler, shorter way I'm telling you right now. Don't worry, I'll tell you the expanded form also, but right now let's do it in this way. 1 squared is 1. It's x squared plus 2x plus 1. Then x squared negative 1 is equal to, now it's 2x squared because 2 get multiplied to each and every term. 2x squared plus 4x plus 2. Now what we do, we can either bring that terms to this side or even these terms we can bring to this side. Equally, it's okay. Let us bring these many terms to the other side. So this is already x squared and we bring this 2x squared to this side. So that becomes negative. It simply becomes negative. We bring 4x, it also becomes negative. We bring 2, that's also negative, and 1 is already present with the negative sign here. We write this negative one as it is. 1 second. It will be clear to you when I use different colors. We had x squared negative 1. No matter where you write, whether you write here or there, that's no matter. And nothing is left to the other side, so it's 0. Okay, then we simplify this. X squared negative 2x squared is just negative x squared. Negative 4x, negative 2, negative 1 is negative 3. Now see, it looks awkward. All the terms have the negative sign. It's better to multiply with the negative sign at both the sides in order to get rid of these many negative signs. So we rewrite the expression as it is, and both the sides we're going to multiply with the negative sign. So what does do that? This negative sign simply get combined with each term. So it makes all of them to their opposite symbol. They all were negative, so they all become positive. Zero doesn't matter whether it's negative or positive. So zero. This is the simple standard form we got right now. Okay.
Mhm.
Now we have to factorize it. And this time it will be pretty easy. X squared plus 4x plus 3 is equal to 0. You have to split the middle term, which is 4, and whether to use positive or negative sign in the middle, addition or subtraction. So A and C is positive or negative? Can you tell me?
Positive.
Positive. So it simply means we're going to use a positive sign, addition sign here. And 3 is only the product. So 3 is factorized as 3 and 1. So I told you when that number is insufficient, you can also utilize this. So now that's going to be 3 plus 1. 4 is what? 3 plus 1. X squared plus 3x plus 1x plus 3 is equal to 0. That got multiplied with both the terms. We take x common, we got x plus 3. We take 1 common, we again got x plus 3. That's what we wanted. So x plus 3, x plus 1 is equal to 0. Then we get x plus 3 equals 0, x plus 1 equals 0, x equals negative 3. This is negative 1. These are the two answers. What did you get in these as two answers in that question?
Um, I got -3, positive. Oh, but I went wrong in the before step. Like,
Mm,
yeah,
okay,
I
so
didn't add them together, right?
all right. So I think when you follow this method, I think there is less margin of error, and I think that looks perfect to me. And if you find
Oh,
it, yeah,
I couldn't get that. I didn't get x squared plus 4x.
this one.
Yeah, I get it now, but I didn't get it when I did it.
Okay, earlier. Actually, this negative sign got combined here with each term like that, right? That's
Mhm.
why. And what do you feel, Tiana? Are you available more than one day in a week? Because I feel like your content is little bigger. So isn't it okay if we have two sessions in a week? If it's required, if you feel like
Um,
that you need that.
um, I'll see.
Yeah, just because
How,
it depends
yeah.
upon you. If you feel like it's just kind of optional. I'm not forcing it to you. Just if you feel like that, yes, I need that, so I can arrange an extra session for you if you want each week. So 2 hours per week, I guess, according to because you have a big curriculum in the 10th grade, so that might be
Yeah.
needed. So if you can manage the time, you may let me know so that we can have additional sessions. So I think that will be
Mhm.
great. Well,
Yeah.
is there any doubt in this question?
No.
This is where some extra thing we had to do, that this is a kind of identity we applied. Suppose you don't want to apply the identity and you only have x negative 1, x plus 1. You don't know the formula. So what you will do, you will take this x and you will multiply this to the entire bracket. Then you will take this negative 1 and you will multiply this to the entire bracket like this. So x squared plus x, this get multiplied like this. Negative 1 is also multiplied to that, negative x, negative 1. So x squared, this got cancelled, negative 1. That's what we got only there, as you notice. We got x squared, negative 1 only. Look at this. This is where we perform long multiplication. It's called long multiplication. And there we just use the formula that's called identity. We simply use the formula a squared minus b squared. Formulas are written over here. A plus b, a minus b. It could have also been written a minus b, a plus b. That's still okay. That will still be equal to a squared negative b squared. We just because in multiplication we can switch the signs, like we can switch the places of the terms. You can still go through this step and ask me if anything, if any step is doubtful. When you tried the question, did you use these formulas or just simply you did the long multiplication?
The long
Okay,
multiplication.
let me now just do it in that way only. Suppose we have got, I'll just get this standard form and then you can just copy the expression that we did. But see, this is the question, x negative 1, okay, 2x plus 1 whole squared. So 2x plus 1 whole squared can be written as 2 times x plus 1, x plus 1. If you don't want to apply the formula, right?
Mm-hmm.
At the right hand side, did you apply the formula or not?
Um. Oh,
Can you send me the picture that
yeah,
what you did? Just
yeah, I
send me
did.
the picture. I think I'll be able to understand how exactly you did. Okay. Uh, okay, negative x. Yes, you expanded it. Yeah, you expanded it, but you didn't write. I think you must have done it at. Okay, I think you have used FOIL method. First, outer, inner, last. Did you use that method?
Yeah,
FOIL. Okay, even that method can be applied. Yes, FOIL method. See, this is first. So first of all, we write first here. The first terms are first, x and x, right? Then outer are x and 1, right? Then inner are negative 1 and x. Make sure to keep that negative x. And the last terms are negative 1 and 1. Similarly, here you keep this 2 here. And then you write first, so first x and x. Then outer x times 1. Then inner are 1 times x. And last are 1 and 1. Right? So you get x is squared plus x, negative 1. Here you have 2x squared plus x plus 1. Let me see if you uh, did the same thing. Here you wrote a negative sign. There is negative. Is it negative or positive? Oh, I think it's positive only. Never mind. Um, you then multiplied 2x squared. Okay. So okay, x squared. This got cut actually. Did you cut them? X negative x?
I don't know.
Just because
I have
positive
no
and negative
idea.
x will be cancelled by together, right? And even
Mm-hmm.
here you could have just written like 2x squared plus 2x plus 1. I think that's what you, I don't know what you did here. I
Yeah, I
think,
don't know.
yeah, okay, you didn't actually simplify it, but you exactly did the similar thing. Whether you uh, add them or simply multiply as it is, it's still okay. So you get 4x
Mm-hmm.
plus 1 here. This is x squared negative 1. And you factorize it with some other method, but that's what I was telling to you. Like every time when you try those methods, they have some limitations. So sometimes you may have some mistakes, but look at this method. Once you got this expression, the standard form, it's really smooth. There is no margin of error. You can directly do it and without any error, and you get the right answer. Okay? Don't worry. I'll just send the recording of this session to you so that you can watch again exactly what to do in different questions. Now we have got, actually I have another session, but if you want, I can continue with few more questions quickly. Should I?
I don't mind.
Okay. Let's have at least one question, then we can wind up. I think you sent two more pictures to me. Let me just open that. Mm, yeah. This is the one question we had. Can you see this?
Mm-hmm.
And the other question is this one. One second. I think let's begin with this question first. Let's do it quickly. Look at this. It says the product of one more than a positive number and the same positive number halved gives the an answer. Okay, means they're just talking about certain number. So let the number be x. The first thing that you have to do, you have to assume a variable for the number, right? So you simply assume let the number be x. They said the product means multiplication of one number, one more than a positive number. So product of what? Product of two things. Product of two things. That the first number, okay, let me just write down. Product of two numbers, basically, it's not the number, it's the first thing. First combination, you can say. I'll just write it in that way. The first thing here, the second thing here. Product of two things is equal to 136. That's the main thing here, right? They said product of certain one more than a number and the same positive number halved gives that much answer. It's 136. So one more than the positive number. So one more, see, x is the number. So one more than will be x plus 1. Or I can just write down here. Multiplied one more than the number. And the other number is same positive number halved. So half of the number. So one more than the number is x plus 1. And half the number is x over 2. Right?
Mm-hmm.
That is equal to 136. Now we can also write x plus 1 multiplied to x over 2. We can write it in this way because this is kind of 1 here. So 1 times 2 is 2. Now this 2 goes to the other side into multiplication. So we it becomes 136 times 2, 272. And here it get multiplied to both the terms. So x is squared plus x. We bring 272 to this side. It's negative 272 is equal to 0. So that's the standard form, right? That's a kind of standard form. And now we have to factorize it. So what we do, we can consider this to be, see, this is my standard form. And then we have x is squared plus, see, if there is no coefficient, we can assume that to be 1 here. And then this is negative 272. And so we have to split the middle term right now again. What sign you will have to use? Can you just guess?
Negative.
Negative sign. Subtraction sign you will have to use because C is negative this time. So one thing is clear that when you multiply A and C, let's quickly do this. A times C is 1 times negative 272. That gives you negative 272. That's a negative number. So perform subtraction. Now let us factorize it. 2 ones are 2, 2 threes are 6, 2 6 are 12. I'm just doing it a little quickly because I have another session just after you. So I'll have to be a little quicker now. Okay. Now we need one here, right? And that's really simple. See, 2 twos are 4, 4 twos are 8, 8 twos are 16. That gives you 16. And this is 17. What does it mean? 17 minus 16 is what? 1, isn't it? Yeah, and yeah, that's it. We can just go to perform factorization. 17x negative 16x negative 272. We take x common, we get x plus 17. We take negative 16 common, we again get x plus 17, that's equal to 0. X plus 17 and x negative 16 is equal to 0. We get two answers actually. X plus 17 is equal to 0. X negative 16 equals 0. They said it's a positive number, right? So this will be discarded. In word problems, most of the times one answer is discarded because that doesn't make sense. They said positive number and we got negative here. So that will be discarded. Only this will be the correct answer. The number is 16. Okay, okay, Tiana, tell if you have any doubt in the question.
Um, how do you why did you like how did you get it and then times
Where? This one?
no the whole thing
Uh,
stuff.
didn't, are you saying did you get, like, you did not get anything in that question?
No, no.
Okay, the question said the product. Product means what? Multiplication, right? Product means
Mm-hmm.
what? Multiplication means we have to multiply two things. We have to perform multiplication with two things. The first thing is one more than the positive number, one more than the number itself, right? So one more than the number itself is what? X plus 1, isn't it? And other thing that we have to multiply is half the number, means number over 2, that is x over 2, because we assume the number to be x. And then we just perform simple calculation. We multiplied it, we simplified, we converted it into the standard form, and then we got the answer like that.
Mm-hmm.
Okay, Tatiana, let's do one thing. Let's end right now and just go through it. And if you don't get it, just
Okay,
just ping me on my WhatsApp. As soon as I just finish my lesson, I'll respond back to you.
okay.
Okay, I'll share the recording with you later. I think after some time because it will take time to be converted and then uploaded. So I'll share it with you as soon as I get the time. And one more
Mm-hmm.
question is left so that I can also cover either in the next session or if you need that early, I can send it to you by simply solving it on a piece of paper and then I'll send you the solution.
Mm-hmm.
Okay.
Okay.
All right then, Tiana. And we'll have to wind up now. Anything else
Yeah.
you can quickly ask from me if you want to ask right now?
No, don't worry.
Okay. All right, Tiana. So we can wind up then and we'll talk more in the next session then. You can also talk
Mm-hmm.
to me on my WhatsApp if you need any assistance. All
Mm-hmm.
right. Okay then. Bye bye. Take care.
Bye. Thank you. Thank you.